Hare Krishna. This is my 14th video, and today I am going to take the nth order derivative. That is the derivative of a nth order. So in the last session we have studied about the derivative of a higher order, that is the second order we have studied, and we have taken so many examples, isn't it? So today I am going to take, that is the nth order derivative, and that is the last unit of derivative, or you can say the differentiation, isn't it? The last unit. So what do you mean by the nth order derivative? You know the first order, you know the second order. In this way you can find out the third order, and the third order, fourth order, and in this way you can find out the nth order. But whenever you find out the nth order derivative, your first order, second order, third order, that derivative should be in the form of the one of the sequence. In the form of a sequence, then and only then you can find out the nth order derivative. You can't find out the nth order derivative of any function. Some particular functions are there. For that function only we can find out the nth order derivative, because their derivative, the derivative of that such a function, we will get in the form of the sequence, right? ज्या फंक्शनची डेरिव्हेटिव्ह एखाद्या सिक्वेन्सच्या फॉर्म येते, म्हणजे 1 नंतर 2, 2 नंतर 3, 3 नंतर 4 असं आलं की आपण डायरेक्ट काय म्हणतो, 1 2 3 अप टू व्हॉट हिअर n, 1 3 4 1 3 5 7 up to what here, 2n minus 1, isn't it? So in this way you can find out the nth term by observing or by making some calculation, isn't it? So when the derivative of a first order, second, third, if it is in the form of a sequence, then and only then you can find out the nth order derivative, otherwise not. So there are some particular functions are there, so that you can find out the nth order derivative. Let us start. Nth order derivative. Nth order derivative. So I will take the first example, that is y is equal to x raised to m. See, there are the three cases. Suppose I write y1, that is m into x to the power m minus 1. y2, again m minus 1, isn't it? X to the power m minus 2. Again y3, m minus 1, m minus 2, x to the power m minus 3, isn't it? So in this way you can find out yn. Again, if you observe this, this is the third order, and here you have got m minus 2, right? The third term here you have got as a n, that is one term get less, isn't it? Since this is the y3, means the derivative of order 3, you have got what here, m minus 2, isn't it? And here first order derivative m minus 1, second order derivative m minus 2, third order derivative m minus 3, so nth order derivative m minus n. But here you can write m minus 1, m minus 2, isn't it? Dash 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 m, one get less here, that is m minus n minus 1 you have to write, isn't it? And into x to the power m minus n. This is the nth order derivative. But to bring in a standard form, standard formula, what you have to do, because m, that is the any integer, and you can substitute here any value here, right? So we should get the standard form. For that purpose, see what you have to do. This is yn, it is equal to m minus 1, again m minus 2, dash 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 m minus n minus of minus plus 1, isn't it? And into x to the power m minus 1. Now what you have to do, m minus 1, m minus 2, this you can write as a m minus n plus 1. The next term, one term get less here, right? Now that is the factorial. What do you mean by the factorial 5? That is 5 4 3 2 1, isn't it? You can reduce like this. So here also what you have to do, the next term of this is n minus n plus 1, but one term we want less here, right? Therefore, because here m minus 1, m minus 2, आपण काय करतो, एक एक कमी करत जातो. तर इथे सुद्धा मी एक कमी करत आहे, म्हणजे m minus n, राईट, एक ने कमी केलं, my m minus n minus 1, isn't it? my m minus n minus 2, कमी 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 करत होत काय होतं, लास्टला 2 1 पर्यंत पोहोचतं. द सेम टर्मनी मी इथे डिव्हाइड करत आहे. या टर्मनी मल्टिप्लाय केला. आय हॅव मल्टिप्लाइड विथ व्हॉट हिअर m minus n, m minus n minus 1, m minus n minus 2 अप टू व्हॉट हिअर 2 into 1, isn't it? रिड्यूस होऊन जातो, पूर्ण 1 पर्यंत रिड्यूस होतं. सिमिलरली m minus n, then comes m minus n minus 1, m minus n minus 2, that is up to what here 2. सेम टर्मनी मल्टिप्लाय केलं, सेम टर्मनी डिवाइड केलं, and into what here x raised to m minus n. Now again if you observe this, the numerator you can write as a m factorial, the denominator you can write as a m minus n factorial, and here the result, that is m minus n, isn't it? So the nth order derivative, if your function, that is y is equal to x raised to m, then what is the nth order derivative? That is factorial m divided by m minus n factorial x raised to power m minus n, isn't it? So here you have got, that is the nth order derivative of the function x to the power m, isn't it? Now the case second here, suppose m is equal to n, then what is the nth order derivative? Yn is equal to, now in place of this you can substitute n, again in place of this n minus n, right, and in place of this n minus n. Now here you have got n, that is n factorial, 0 factorial means 1, and here again x to the power 0. Therefore the second result, that is n factorial, anything to the power 0, that is always equal to 1, and the 0 factorial, it is nothing but what here 1. Therefore yn, it is equal to what here, that is n factorial, isn't it? So suppose, see here, suppose suppose y is equal to x to the power 3, then y3 must be factorial 3, isn't it? Because m is equal to n. Now see, try to find out this. Y1 is equal to 3x square, again y2 is equal to 3 into 2 into x, and again y3 is equal to 3 into 2 into 1 into x to the power what here 0, means 3 into 2 into 2, that is equal to factorial 3, and here you have got y3 is equal to factorial 3, isn't it? So this is the second result. So it is very, very important. If y is equal to x to the power m, then y1 is equal to m into x to the power m minus 1, y2 is equal to m minus 1, x to the power m minus 2, again y3 is equal to m minus 1, m minus 2, x to the power m minus 3. In this way, yn you have got as a, since this is y3, here you have wrote as a m minus 2. Therefore, since this is yn, I have wrote that is n minus 1. Since this is the third order derivative, and here we have got 2. Since this is the nth order derivative, we have got n minus 1, isn't it? एक नि कमी इथे लिहावं लागतं. इथे 3 आहे तर इथे 2 आहे, मग इथे n आहे तर इथे काय लिहावं लागेल तुम्हाला n minus 1. Therefore x to the power here m minus n, because first order m minus 1, second order m minus 2, third order m minus 3, therefore nth order m minus n. Then I have multiplied with what here, that is m minus n, m minus n minus 1, m minus n minus 2, reduce केलं. कुठपर्यंत reduce होतं ते 1 पर्यंत. त्याच टर्मनी खाली पण मल्टिप्लाय केलं. Therefore here you have got the standard result, that is m factorial divided by m minus n factorial and into x to the power m minus n. The second case is that if m is equal to n. If m is equal to n, then you have got, in place of m factorial you can write as n factorial. In place of m you can write n. In place of m again you can write n. This is n factorial. N minus n, 0 factorial means 1, and x to the power 0, that is always equal to 1. Therefore the nth order derivative, that is the second case, if m is equal to n, you have got as a factorial n, right? And if here, that is, suppose n greater than m, third case, n greater than m, means what here? Whatever the derivative you have to find out, suppose that is greater than m. Suppose y is equal to x to the power 3, and we want to find out y4. Then y4, it is always equal to 0. See, that is y1 is equal to 3x square, y2 is equal to 3 into 2 into x, y3 is equal to 3 into 2 into 1, x to the power 0 means that is equal to what here 1, isn't it? And again this is 3 into 2 into 1 means factorial 3 and the derivative fourth order, since this is the constant, it is equal to 0. Therefore, whatever the power, if this power it is m and whatever the derivative you have to find out, that is suppose greater than m, then the result is, that is what here, 0. Therefore, here if in this case if n greater than m, then yn it is always equal to 0. Suppose these are the three cases about what here, nth order derivative. Now I will take the second example. See, m ground. Here you have got, that is the result, x raised to m. You have got as a yn is equal to m factorial, m minus n factorial, and x to the power m minus n. Suppose I consider y is equal to ax plus b whole to the power m, isn't it? In place of x, what is there? Ax plus b whole to the power m. Again, y1 is equal to m ax plus b whole to the power m minus 1, and the derivative of ax, that is a. Again, y2 m minus 1 ax plus b whole to the power m minus 2, and again the derivative of ax, that is a, means a square, isn't it? Again here, see what you have to do. Y3 is equal to m minus 1 m minus 2, right? Again ax plus b whole raised to power m minus 3, and this is nothing but what here, a cube, isn't it? So yn it is equal to m minus 1 m minus 2 dash dash dash, again m minus n minus 1 into ax plus b whole raised to power m minus 3, and into what here, a cube. This is your nth order derivative. Again, this you can write in this form, that is m minus 1 m minus 2 dash 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 m minus n plus 1. Suppose you multiplied here, see, suppose here again you multiplied with m minus 1 m minus n m minus n minus 1 and dash up to what here, 2 into 1. Again, suppose you have divided m minus n m minus n minus 1 dash dash 2 into 1, and here again ax plus b whole to the power, this is m minus n, and this is also m minus n. Since the first order m minus 1, second order m minus 2, third order m minus 3, nth order m minus n, isn't it? First order a, second order a square, third order a cube, nth order a raised to n, isn't it? Therefore here m minus n and a raised to. Now again, this term, that is numerator, you can write as a factorial n divided by m minus n factorial, right? Again ax plus b whole to the power m minus n and into a raised to n. This is the result, isn't it? So this is the second one, second problem, right? Now the third one, see, the third one, I will take here y is equal to, suppose 1 upon x, isn't it? y1, what is the derivative? Minus 1 divided by x square. y2, again we want a sequence, therefore don't rub the terms and or don't reduce, you should get the sequence, right? This is minus 1, and again what is the derivative? Minus 2 divided by x cube. Now the minus 1, how many times multiplied? 2 times, therefore minus 1 to the power 2, and here minus 1 into 2, that is you can write as a factorial 2 divided by x cube. Again y3, this is minus 1, minus 2, minus 3 divided by x raised to 4, again minus minus minus, minus 1 to the power 3, 1 2 3 means factorial 3 divided by x to the power 4. This you can write, right? Similarly, you can write you can find out nth order derivative. See, the third order minus 1 to the power 3, Second order minus 1 to the power 2. First order minus 1 to the power 1, right? First order minus 1 to the power 1. Second order minus 1 to the power 2. Third order minus 1 to the power 3. Nth order minus 1 to the power n. Isn't it? First order factorial 1. Second order factorial 2. Third order factorial 3. Nth order factorial n. Isn't it? Again, first order the power is 2. Second order the power is 3. Third order the power is 4. Nth order the power is n plus 1. Therefore, here if y is equal to 1 by x, then the nth order derivative you have got as a minus 1 to the power n factorial n divided by x to the power n plus 1. Isn't it? So, in this way, don't minus plus 1 into 2, don't write like that, because we want a particular type of a sequence. Once you have got the sequence, then and only then you can find out the nth order derivative, otherwise not, right? So, we required a terms in the form of a sequence, isn't it? Now, the fourth one, see, y is equal to log x. Again, y1, log x 1 by x, y2 minus 1 upon x square, y3 minus 1 minus 2 divided by x3, again y4 minus 1 minus 2 minus 3 divided by x to the power 4, isn't it? Now this minus sign multiplied how many times? 3 times. Minus 1 to the power 3. 1 to 3 means factorial 3, x to the power 4, right? Minus 1 multiplied 2 times. Again 1 to factorial 2 divided by x cube. Here again minus 1 to the power 1 factorial 1 divided by x square. And here again minus 1 to the power 0, again 0 factorial, and here again x, isn't it? So, the first order minus 1 to the power 0, 0 factorial divided by x. Second order minus 1 to the power 1. Second order minus 1 to the power n, 1 factorial 1 divided by x square, isn't it? Third order minus 1 to the power 2 factorial 2 divided by x cube. Fourth order minus 1 to the power 3 factorial 3 divided by x to the power 4. Therefore, what is the nth order here? That is minus fourth order minus 1 to the power 3. Nth order minus 1 to the power n minus 1. Fourth order factorial 3. Nth order n minus 1 factorial, isn't it? And divided by fourth order x to the power 4. Nth order x to the power n. This is about the fourth one, isn't it? Again, I will take the fifth one, isn't it? See, very simple. Some particular functions are there only. Suppose y is equal to cos x. Now see, again if you try to find out usual way, the derivative of a cos x minus sin x. The derivative of a minus sin x, that is equal to minus cos x. The derivative of a minus cos x, again sin x. Sin x cos x, sin x cos x. What is the sequence? Where is the sequence? Can you find out the nth order derivative? So, for that purpose, see what you have to do. First, y1, the derivative of a cos x, that is equal to minus sin x. Now, that minus sin x you can write as a cos of pi by 2 plus x. Because whenever there is a pi by 2, cos it is converted into sine, and pi by 2 plus theta lies in the second quadrant, and in second quadrant the cos ratio is negative. Therefore, here you have got negative. Therefore, minus sin x you can write as a cos of pi by 2 plus x, right? Now, the second order, see here. You have to find out the derivative of this. Cos u, chain rule, minus sin pi by 2 plus x. Again, the derivative of a pi by 2, 0, x, 1. Therefore, no need to write anything here. Again, this minus sin pi by 2 plus x you can write as a again pi by 2 plus this theta means pi by 2 plus x, isn't it? And here pi by 2 plus pi by 2 you can write as a 2 pi by 2 plus x. Don't rub to get cancelled, isn't it? Again y3, cos u, that is equal to minus sin u, means minus sin 2 pi by 2 plus x, isn't it? Again minus sin theta you can write as a cos of pi by 2 plus this angle that is 2 pi by 2 plus x, isn't it? Therefore, again here pi by 2 plus 2 pi by 2, that is equal to 3 pi by 2 plus x, right? Now here you have got the sequence here. Therefore, you can find out the nth order derivative. See, first order pi by 2 plus x, cos of pi by 2 plus x. Cos असेल तर cos आलेला आहे इथे. y2 again cos of 2 pi by 2 plus x, y3 cos of 3 pi by 2 plus x, yn cos of n pi by 2 plus x. Right? This is the fifth one. Again I will take the sixth one. Sixth, see, that is y is equal to sin x. Right. Again y1. The derivative of sin x, that is equal to cos x. Again this you can write as a sine of pi by 2 plus x. Now see, whenever there is a pi by 2, 3 pi by 2, 5 pi by 2, sine it is converted into cos. Again pi by 2 plus theta lies in a second quadrant, and in second quadrant the sine ratio it is positive. Therefore the sine of this cos x it is positive. Therefore sine pi by 2 plus x it is always equal to what here, cos x, right? This is the first order derivative. Again y2. This you have to find out here. Sin u means cos pi by 2 plus x, isn't it? Again this cos pi by 2 you can write as a sine of pi by 2 plus this angle, that is pi by 2 plus x, isn't it? Again pi by 2 plus pi by 2 x you can write as a sine of 2 pi by 2 plus x. So similarly you can find out the nth order derivative, that is sine of n pi by 2 plus x. Right? This is the sixth one here, right? So I will take the seventh one. Seventh, y is equal to e raised to ax plus b. Again very simple. Again y1. The derivative of a to the power u, e to the power u, ax plus b, and the derivative of a x, that is a. Again y2. E raised to ax plus b, ax plus b. The derivative of a ax, that is a, means a square. y3. E raised to ax plus b. Again a cube. Similarly yn is equal to e raised to ax plus b. And since third order a cube, nth order a raised to a. Quite simple, right? Now the eighth one. Y is equal to a to the power bx plus c. Again the first order. The derivative of a raised to x, that is a raised to x log a. Therefore a derivative of a raised to bx plus c, it is equal to a raised to bx plus c into log a, and the derivative of a bx, that is b. Again y2. This log a and b, this constant term remain as it is. Again you have to find out the derivative of what here, a raised to bx plus c. A raised to bx plus c, that is a raised to bx plus c into log a into bxb, and this term remain as it is, log a and b remain as it is. Therefore here you have got a raised to bx plus c, again log a whole square, and here you have got as a b square. Similarly y3 you can find out a raised to bx plus c, again log a whole cube and b cube. Right? Similarly you can find out yn. Here a raised to bx plus c, log a whole to the power n and b raised to a. Right? This is the 8th example. Again. Ninth example. Suppose the function is like this, y is equal to 1 upon ax plus b, isn't it? Again what is y1? The power that is equal to 1 means minus 1 divided by ax plus b whole square. and the derivative of ax, that is equal to a. y2, again minus 1, minus 2, ax plus b, whole raised to 3, and the derivative of ax, that is a, means here you have got a square. Again y3, minus 1, minus 2, minus 3, divided by ax plus b, whole raised to 4, and here you have got a cube, isn't it? So this you can write as a minus 1 multiplied 3 times, therefore minus 1 to the power 3. 1 to 3 means factorial 3, a cube, divided by ax plus b, whole raised to power 4. Here minus 1 multiplied 2 times, again 1 2 means 2 factorial, a square, divided by ax plus b, whole raised to power 3. Again minus 1, this is ax plus b, whole to the power 2, isn't it? Similarly, you can find out yn. Again, first order derivative minus 1 to the power 1, right? Second order derivative minus 1 to the power 2. Third order derivative minus 1 to the power 3. Nth order derivative minus 1 to the power n. First order derivative factorial 1. Second order derivative factorial 2. Third order derivative factorial 3. Nth order derivative factorial n. First order derivative power, the power of a1. Second order derivative, the power of a2. The third order derivative, the power of a3. The nth order derivative, the power of a, that is n. Again, first order derivative, the power ax plus b, that is 2. Second order ax plus b, the power is 3. Third order ax plus b, the power is 4. Nth order, the power of ax plus b, that is equal to n plus 1. So this is about the 9th one, isn't it? Now the 10th one, see. 10th one. Y is equal to e raised to x sine of bx plus c. See, this is little bit complicated because there are the two terms are there. First, y1. Apply multiplication rule. E raised to x remain as it is. The derivative of a sine u, that is equal to cos bx plus c. The derivative of a bx, that is b. Again, sin bx plus c remain as it is. And the derivative of a e raised to x into a. Again, you can take e raised to ax common, isn't it? Here you have got b cos bx plus c and a sin bx plus c, right? Again, this is a very big term. Suppose you try to multiply it. Suppose you try to apply the multiplication rule, that is too lengthy. Therefore, what you have to do? You have to reduce this function. For the reduction of this function, see what you have to do. You have to multiply it and divide it with what here? Root of a square plus b square. Now I am going to multiply root of a square plus b square into e raised to x. Here also you have to multiply, that is b divided by root of a square plus b square cos of bx plus c and a divided by root of a square plus b square sin bx plus c, isn't it? Again, if you observe this, here if you observe this, that is a divided by root of a square plus b square whole square and b divided by root of a square plus b square whole square, it is equal to 1. Therefore, this identity satisfies the trigonometric constant, that is the trigonometric constant satisfies this identity. If you substitute, this is cos alpha, and if you substitute, this is sin alpha, then sin square alpha plus cos square alpha is equal to 1. Therefore, in place of this, that is a divided by root of a square plus b square, you can substitute as a cos alpha. Therefore, a divided by root of c here, I write, put a divided by root of a square plus b square, it is equal to cos alpha, and b divided by root of a square plus b square, it is equal to sin alpha, since here since a divided by root of a square plus b square whole square and b divided by root of a square plus b square whole square, it is always equal to 1. Therefore, here we have got that is root of a square plus b square e raised to ax. Again, sine of this function I will write first, sine bx plus c into cos alpha plus cos bx plus c into sine alpha, right? Into sine alpha. And this you can write as a root of a square plus b square e raised to ax, and this is sine a cos b plus cos a sine b. This is the formula of a sine bx plus c plus alpha. This is your first order derivative, isn't it? Now to find out again the second order derivative, again by 2. This remain as it is, a square plus b square remain as it is. Here you have to apply the multiplication rule, e raised to x and sine bx plus c plus alpha. Now this term get reduced because this is so big term here, and this term get reduced to what here, sine bx plus c plus alpha. Again apply the multiplication rule, e raised to x remain as it is. The derivative of a sine bx plus c plus alpha, that is equal to cos of bx plus c plus alpha into the derivative of a bx, that is b, isn't it? Again sine of bx plus c plus alpha remain as it is, and the derivative of e raised to x, that is e raised to x into a, isn't it? So again what you have to do, root of a square plus b square. You can take common, that is e raised to ax, and here again you have got that is a sine bx plus c plus alpha and b cos of bx plus c plus alpha, isn't it? Now again what you have to do, divide both numerator and denominator by what here? Divide both numerator and denominator by root of a square plus b square, right? Then you have got, see here, you have got the result. See, I write here, that is y2 is equal to, suppose you divided with and multiplied with, isn't it? Multiplied the numerator and, multiplied and divide, isn't it? So when you multiplied here, divide and multiplied only, divide and multiply by what here? Root of a square plus b square. Now when you multiply, you have got that is root of a square plus b square whole square, isn't it? Now here e raised to ax remain as it is. Here you have got that is a divided by root of a square plus b square sine of bx plus c plus alpha and b divided by root of a square plus b square into cos of bx plus c plus alpha, isn't it? Now again what you have to do, in place of this here, again in place of that is a divided by root of a square plus b square, you can substitute as a cos alpha, and here you can write as a sin alpha. Therefore here the y2 you have got as a, that is root of a square plus b square whole square e raised to ax remain as it is, and in place of this again you can write the sin bx plus c plus alpha remain as it is. This is cos alpha plus, in place of this you can write as a cos alpha, and here cos bx plus c plus alpha and into what here sin alpha, right? And again if you observe this, this is the formula of, say, y2 is equal to root of a square plus b square whole square, here e raised to x remain as it is, sin a cos b plus cos a sin b, again sin of b x plus c plus 2 alpha, isn't it? And this is the second order derivative, and in this way you can find out the nth order derivative, that is yn is equal to y to the power is 2, yn the power is n, the power n is e raised to x remain as it is. Here again sin of bx plus c y2 2 alpha yn, that is n alpha. So this is the nth order derivative of that function. So here I have finished, that is the nth order derivative, and the 10 example, that is the main example I have taken, isn't it? And here I have completed the total differentiation, that is the derivative, isn't it? So in this derivative, we have studied, that is the first chain rule, then comes the logarithmic, then comes the inverse trigonometric function, then comes logarithmic differentiation. After that, we have studied the derivative of a implicit function. Then we have studied the derivative of a parametric function. Then we have studied the second order derivative, and the last, that is the nth order derivative. This is a very big chapter. So many functions are there, and there are also the miscellaneous exercise. That miscellaneous exercise, it's very necessary to solve it, because the in CET, the every problem, it is from what here, the miscellaneous. So it is compulsory to solve the miscellaneous. There are the very good problems in the miscellaneous. Also the MCQs are given in your book, that is the board book, isn't it? That also helps for what here, JEE. The JEE you can't get at once by taking the classes, that is the outside classes, whatever the classes that is in the wherever the classes are there, but you uh, can't learn JEE at once. First you have to learn what here, the board book, then you have to learn CET, and then you have to solve the problem on JEE, isn't it? At once you can't solve the problem on JEE. Therefore, we have to take step by step. First, we have to solve the board, then we have to take the problem on CET, and then you have to take the problem on what here, JEE, isn't it? So this is the way to study. So here I have finished the first chapter, that is the differentiation, or you can say derivative, in 14 videos, isn't it? 14 videos I have taken the 14 videos, because to complete this chapter. Then also we are not completing deeply, but the maximum problems I have taken, isn't it? So that you can study yourself, isn't it? Self study you can do. So the student, if you like my video, then share it and subscribe my channel. And if your any comments are there, please give me the suggestion. I will recover. I will trying to give the answers, or give the answers to your comments, or accepting your suggestion. Thank you. Good day for you.